Howdy, gang. I'm so happy you're back and you're taking the time to make yourself a better chemistry student and understand even more. Um, Wonderful to see your face. Um, no, I'm just kidding. I'm not really looking at you. But anyway, here we are. This one should be pretty quick. This is the expanded octet. And the truth is, I probably should have continued this in with the last one, um, but I stopped, and I guess I could go back and edit that. But anyway, so here's the deal. Let's take a look at this, and you guys know by now we have this game called in chemistry. Hey, we make rules just to break them. Um, Here's a wonderful example of this. Okay, so in this case, you have what's called an expanded octet, and what you see are main group elements that form more bonds that would be predicted by the octet rule. In other words, these are guys that exceed the octet rule. So you have what is called a hypervalent compound. Hyper meaning above. Okay, so this is literally above valence and expanded octet meaning larger than 8 as well. And this is always around the central atom. So when we consider something being expanded, we are always looking at the central atom. Okay, so we're not doing this for the outside, the central atom only. These atoms that are able to expand the octet are those that utilize the D sublevels that are found in the third principal energy level and beyond. Okay, so your common players, your guys, the usual suspects are sulfur, phosphorus, arsenic, and chlorine. If we flip on over to our periodic table, these guys are the ones that must be in the third period or beyond. So from here on over, okay? So all of these guys can do that. Remember, we're not doing that anything here because those are metals anyway, and they give rather than share, okay? So we're going to get rid of this sort of thing. Anyway, if you look at that, the usual suspects are phosphorus, put a little check here, phosphorus, sulfur, chlorine, arsenic, selenium, antimony does it a lot. You see xenon, we get him to react a little bit. There are some others, but those are the guys that you just kind of sort of have to embrace as troublemakers, okay? So let's spend a moment or two when that cleans up. There we go. Spend a moment or two doing a few examples. So PCl5. One clue that you realize that you're above your octet is if you look at that's 5. You're not going to see any atoms really begin to string themselves along in terms of chains, with the exception of carbon. And so again, for PCl5, you're going to see 5 from phosphorus, so 5 electrons here from phosphorus, plus 35 electrons from chlorine, which means you got 40 electrons or 20 pair. Okay, and again, I just start building these and kind of sort of sticking them on here. So phosphorus is in the center. You've got 5 chlorines you have to find homes for. You might as well do that. That almost looks like a Cl. 1, 2, 3, 4, 5 pair. So you can see he's exceeded. You cannot attach 4 chlorines to something like this. Sorry, 5 chlorines to something like this without expanding the octet. And now I've got another 15 of these to find homes for. So here's 3 more. There's 6 more. There's 9 more. 12 more. And at this stage, you've got 15 extra pairs and 5 more. So if you want to count those up, you can. that would give you 20 pair. And you can see he's expanded. You know he's expanded because he does not satisfy the octet. And again, we're only concerned about the central atom here, not the chlorine. Okay? I'll say this. Typically, these are pretty easy to draw. All right, let's erase this. We'll clean this up. So we have a work surface here. You don't have that luxury. I'm sorry I didn't make that little box big enough. All right, SF6 already, boom, he's expanded. So sulfur brings 6, fluorine brings 42, and that 42 electrons are, you have 6 of these guys that each bring 7. So that's 48 electrons. Divide that by 2 equals 24 pair. So just start putting them on there. You got sulfur in the middle. Okay, fluorine, 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 and fluorine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Perfect. In the next screencast, we'll see that actually these things have very different shapes, and that'll be kind of fun to look at. Let's erase, and we'll do the same song, third verse. Okay, so sorry about that. Didn't mean to sniffle in this headset. It's a little bit gross, my bad. TeBr4. So Te is a sibling of, where is he? He's a sibling of oxygen and sulfur and so on. So he's going to bring 6. I showed you that because sometimes he's tough to remember. So Te brings 6 electrons. You have bromine, which brings 7. You have 4 of them, so that's total of 28. For 34 electrons divided by 2 gives you 17 pair. So let's stick these on here. So Te in the center, because I only have one of those guys. 4 Brs. Just start putting them around here. It doesn't really matter where they go, guys. And then at this stage, 1, 2, 3, 4. You got to connect them. That's a terrible bond. There we go. And I've got 17 pairs, so just start putting them on here. 1, 2, 3, 1, 2, 3. Okay, as you can see, these terminal atoms, outside of being hydrogen or beryllium or boron, they're all going to have 8. So that means I've got 4, 8, let's try that again. 4, 8, 12. 16. I have 17 pair. I know I expand my octet, so that's my 17th pair right there. So guys, that's about it for expanded octet. There's a couple more that you could practice on your own. And if you're struggling with this, watch the screencast again. Get some help from me or one of your peers. But chemistry is not a spectator sport. You get better by doing it. Okay, thanks for dialing in, guys. I appreciate you listening. And do something nice for somebody else, please. Have a great day.